So hello everyone, today we are going to learn what is meant by gradient of a multivariable function and what is the directional derivative and how to calculate the directional derivative from the gradient, as well as what are the tangent vectors. So here in this picture we can see there is a function. Basically that's a multivariable function because this function has three variables that it depends on. So the function f is a function of x, y, and z. Now on this graph, on this surface, this function is actually a surface we can see, and on any point there is a change of the function with respect to each of these independent parameters or each of these variables. So this change is measured in terms of its gradient. So at any point of this function, the gradient is going to be this equation. The gradient of f is equal to, we take the partial derivative of the function with respect to each of these variables, and then we also we form a column vector, and that is going to be the gradient at any point. Now this we can see all of these components, these are actually this contains the variable form of the function's derivative, and that's why this is not fixed at a point. Now if we choose a certain point, x bar, y bar, z bar, and we want to calculate what is the gradient at this certain point, then what we need to do, we just need to put all the values in our gradient formula, and that is going to give us the gradient at this point. So basically we did nothing, we calculate the gradient and then put the values of this point in each of these components, and that would give us some fixed or constant values. Now next we are interested to learn what is meant by a tangent vector. So here on this point, from this point we can go along different direction. So the gradient on this point along the x-axis is del f by del x. So it basically means how much the function f changes if we change x, if we change x at a very small amount. And the tangent vector actually is gonna be this amount, the gradient amount multiplied by the unit vector along the x direction, because here this gradient value is a scalar, so a tangent vector has to be a vector. Basically for that we multiply it with a unit vector. Similarly, along the y and z axis we can calculate the tangent vectors. Now finally, based on the values of the gradient, we can also calculate the directional derivative. So directional derivative is extremely important in optimization problem, but it's often confused with gradient. But it's not the same as gradient, it's different. But it has a relationship with gradient. We can basically calculate directional derivative from the gradient of a function. How? I'm gonna show that. So for that, first consider a vector t. So this is a new vector we are considering t. T is somehow like this is lying on the xy plane where it's kind of in between, creating a certain angle with x, and so we define it as this. So this is t equal to, this is also a vector, 0.5 of x and 0.2 of y and 0 of z. So there is no component along z axis, and that's why this is this is basically a vector that is dependent on only x and y. Now we are interested to see what is the change of this function, or what is the gradient of this function along this vector, and that is called the directional derivative of this function along the vector t, or along this direction t. So it's the same gradient, but it will have a direction along, like the calculation has to be along a certain direction. For that, we'll have to move this vector to this point. So it's going to be this point, and then we can calculate the directional derivative from the gradient values that we just computed. So the directional derivative will be nothing, just the same thing, the gradient, but it's gonna be, we will have a dot product with sorry, this is a typo, this is gonna be t, this is gonna be t. So so we have this gradient, and we also have this this t vector, and when we multiply and take the dot product, we have the directional derivative. So it means the directional derivative basically means how much the function changes along this certain direction. Thank you.